Welcome to this edition of Let's Decode This Architecture. This is Rodriguez Manuel da Silva with Cloud and Technology. Today's architecture to decode is shown on the screen. This is another submission by Jiju Thomas Matthew, an expert in architecting complex solutions on AWS. Scan the QR code displayed near his avatar image to find him on Google search. In the dynamic landscape of server room management, the challenge of effectively monitoring and controlling temperatures while optimizing costs and scalability is paramount. Challenge: outdated custom solution. The client's existing solution relied on Raspberry Pi devices and a central Apache+PHP server for data acquisition, processing, and control. However, this approach led to increasing data center costs, hardware maintenance burdens, and limited scalability for future growth. Additionally, feature development was hampered by the need to manage the underlying infrastructure. The solution to address these challenges suggested an improved system based on AWS best practices, providing a comprehensive overview of the components used and their roles in revolutionizing server room management. To overcome these challenges, a modern architecture based on AWS optimized deployment best practices was proposed. Let's explore the components and their roles in this innovative solution. AWS IoT Core collects sensor data directly from sensors using lightweight protocols like MQTT and securely transmits it to AWS IoT Core for bidirectional communication. AWS IoT Analytics provides real-time analysis of sensor data for anomaly detection and insights generation. Amazon S3 offers cost-effective storage for historical data, ensuring scalability and easy access to past records. Utilizing tiers and lifecycle rules in Amazon S3, it's easy for optimizing storage costs, performance, and management, enabling organizations to effectively manage their data throughout its lifecycle while maximizing value and efficiency. Amazon TimeStream utilized for optimized time series data storage, enhancing efficiency and performance in handling sensor data. AWS Lambda implements serverless functions for data processing and triggering actions based on sensor readings, ensuring scalability and cost-effectiveness. Amazon Cloud Watch centralizes monitoring of sensor data, API gateway performance, and overall system health. Integration with Kibana enables advanced log analysis and visualization capabilities. Amazon API Gateway serves as a secure entry point for sensor data, routing it to appropriate backend services while enforcing authentication/authorization policies. Amazon Athena empowers ad hoc analysis of sensor data stored in S3 for generating reports and historical trends, enhancing decision-making capabilities. Amazon SNS simple notification service triggers notifications via Lambda functions based on CloudWatch alarms, facilitating real-time actions such as controlling chilled air valves and pressure pumps. By leveraging AWS and adopting a modern architecture, the proposed solution addresses the challenges of server room temperature monitoring and control with unmatched scalability, efficiency, and cost-effectiveness. With real-time analysis, historical trend identification, and proactive anomaly detection, this architecture sets a new standard for optimizing server room operations in the digital era. Stay tuned for more like this. Expect to be here every Monday at 9 o'clock with a new episode of Decode This Architecture. Thank you for joining us in this episode. Please do like, share, subscribe, comment to keep us going.